Hello, this is Mr. Abbott. Here today we're going to be talking about solving systems by elimination and multiplication. Now, we've already talked about solving systems by elimination. This just adds a second little step so that we can eliminate the more complex ones. Not a big deal. All the method is pretty much the same. But we're going to use the elimination and multiplication when equations are in standard form, just as before, and when coefficients do not match. For example, what you see in front of you in that one, you see 3x and 2x, they don't match, and 4x and negative, or 4y and negative 3y, and they don't match. Okay, so what are we going to do? We will multiply one or both of the equations to create opposites. Kind of like when we find common denominators. Same kind of technique. So let's take a look at our first one. We have 2x plus 3y equals 6, and x plus 2y equals 5. We don't have a match, but we do have some that are similar. For example, the 2x and the x. Now we could change that x. If we change it to 2, or to negative 2, we'd have something to cross out. So that's what we're going to do. We're going to take this entire bottom line, and we're going to multiply it by 2. When we do that, we're going to get 2x plus 4y equals 10. Now, they still don't have a match, so what we do is like we said before, we change this second line, everything to its opposite, giving us negative 2x minus 4y equals negative 10. Now, that's a lot of steps and a lot of things to write, so what we want to do is we want to think ahead. If we think ahead, we could have actually multiplied this line by negative 2 and skipped over this straight to here. So that's what we want to do. We want to think ahead as much as we can. Save ourselves some time. So if we multiply this bottom line by negative 2, that gives us negative 2x minus 4y equals negative 10. Let's go ahead and cross that out for now so we can look at what we're working with now. All right, so now we have 2x and negative 2x. They will cancel. They will give us 0x. We're not going to write that. We have 3y and negative 4y gives us negative y. And 6 and negative 10 gives us negative 4, which we know is y equals 4. We just take the negative off. We take the opposite of each. So we have our first part. So now we're going to plug in our 4. I'm going to go ahead and plug into the bottom one, the one that we crossed out, because it's a little more simple. So I'm going to have x plus 2 times 4 equals 5, which is going to give me x plus 8 equals 5. I'm going to subtract the 8 and get x equals negative 3. Give me a solution of negative 3, 4. And I'll do a quick check of that. Let's see. 2 times negative 3 is negative 6. 3 times 4 is 12. Negative 6 plus 12 is 6. And we've already worked out on the bottom one. So we're in good shape there. Next, we'll try example 2. Again, nothing that matches. X and 3, 3x, 2y and negative y. But here we have really two options. We can multiply the top line by 3, giving us 3x and 3x. So we have a match. Or we can multiply the bottom line by 2, giving us 2y and 2y. Again, giving us a match. It doesn't matter which way you go. Okay, they're both going to be fine. I'm choosing to multiply the bottom one by 2, simply because I'm multiplying by a positive number. I like that better. And what's going to end up happening is when I multiply this, I get 6x minus 2y equals 4. Now notice when I go ahead and combine, I'm going to cancel that one out. When I combine, I'm going to get a 7x, I'm going to get 0y, and 7. Now not that that's difficult or anything, but if I multiply the top one by negative 3, that would have made all my top row negative and would have made all of this line negative. Okay, now I have nothing but positive, and that's easy, x equals 1. All right, so I'm going to come around and plug in. I'm going to plug into the top one. And I'm going to have 1 plus 2y equals 3. I'm going to subtract that 1 and get 2y equals 2. Give me y equals 1. And a solution of 1, 1. Works out nice and easy. I'll check it real quick. I've already done the top one, so the bottom one, I'm going to have 3 times 1 is 3, minus 1 is 2, and that is correct as well. So I'm off on a roll. Example 3, go ahead and pause this and try this on your own. All right. Here, at first look, we have negative 3 and 1. So we have one that we can solve with no matches. But we can take that bottom and we can multiply it by 3. But again, if we multiply the bottom just by 3, we're going to get 6x, we're going to get negative 3y. That negative 3y doesn't help us. What we want to do is multiply it by the whole thing by negative 3. When we do that, we get negative 6x, we get positive 3y, and we get negative 30. Now, we can simplify. 4 and negative 6 gives us negative 2. Negative 3 and positive 3 gives us 0, so we took care of the y. And 22 and negative 30 gives us negative 8. That's simple to solve. X equals 4. Take it around, plug it in. I'm going to plug into the bottom one and have 2 times 4 minus y equals 10. So that's 8 minus y equals 10. That's going to give me negative y equals 2, so y equals negative 2. And I have a solution of 4, negative 2, which I can then check. I'll check it with the top one. 4 times 4 is 16. 3 times negative 2 is negative 6. 16 minus negative 6 is actually going to plus, which is going to give me 22. And that one is correct as well. Hopefully you did well on that one. That brings us to our next example. Now, on this one, you should notice that we have 4x and 6, 5 and 7. I can't just multiply one line by one number and get a match. So this is where the analogy to the common denominator comes in. I won't multiply just the top line by something. What I have to do is look at 4 and 6 or 5 and 7 and find like I said, a common multiple. I'm choosing to multiply and eliminate the y's. Now, the reason I'm doing that is because I have a positive 5 and a negative 7. So all I have to do is multiply by positive numbers. 5 and 7 both go into 35. So that's what I'm choosing. I'm going to take the top number, or the top line, and multiply it by 7. When I do that, I'm going to get 28x plus 35y equals 42. I'm going to multiply the bottom one by 5 because I've already got the negative here. That's going to give me 30x minus 35y equals negative 100. Now I solve, my y's are going to cancel each other. That gives me 58x equals negative 58. Lo and behold, that's easy. That's x equals negative 1. Bring it back over here and plug it back in. X is negative 1. I'm going to plug it into the top and go 4 times negative 1 plus 5y equals 6. So that's negative 4 plus 5y equals 6. Take the negative 4 over and becomes 5y equals 10 and y equals 2. And I have a solution of negative 1, 2. I'm going to double check it in the bottom. I already did at the top. So 6 times negative 1 is negative 6. Negative 7 times 2 is negative 14. Negative 6 and negative 14 is negative 20. And we are correct once again. So, in conclusion, if the system is in standard form but does not have variables that are the same or opposites, you will create them. First, you choose a variable that would be easiest to change. Second, you multiply all terms of the equation that you're changing. Third, you double check, and this is important, to make sure math is correct. If it is, then add the equations and proceed normally. Double check your math, though, it never hurts. And finally, you're going to write your solution as an ordered pair. Always write your solution as an ordered pair. Finally, you need to make sure you fill out your summary at the bottom of your notes. Always do that. But in addition, and this is for you to help you out for tomorrow, go ahead and go to your books. You should have one at home. And try on page 274, numbers 7, 11, and 13. The answers are in the back of the book, so you can check them. They shouldn't take you long, but they're 3 good examples of what we've been doing. Thank you, and we'll see you tomorrow.